So this is for all the cool cats and kittens who were in here yesterday. I'm advising this B group, so if you're in B group and distance learning, I'm advising them not to actually look at this until Monday night. So we did all of, this is just like your test. Although it might not be poppy seed and gingerbread muffins, it might be fruit salad and whatever, but you'll have two things that you have to set up an objective function for and the constraints for. So we're going to do this one together and then all the other ones, and this is the exact length of your test. What are there, 7 of them on there, Mason? I think, and that's how long your test is. Your first one will be to solve by graphing, just like it is on here, so I definitely look at these. When you do the word problems, always put an X above one of the columns and a Y above the other. Regardless of what they are, column X and column Y, and then go fill in the data. So it says you use 1 cup of flour, so for the lemon poppy seeds, I'll put a 1 there, and a half a cup of sugar. So I'll put a half a cup in the sugar for the lemon poppy seed. Use 1.5 cups of flour and 1 cup of sugar for the gingerbread. So it starts that way. Then it gives you your totals. You have 7 cups of flour, so in the flour row put a 7, and 12 cups of sugar. So that's easy, right, Parker? You just plop the numbers in. Did you put them in the right spots? All right. Then, for the profit, what does it say? $5 and 8. Now, when you set this up, it says, what's the objective function? That always comes from the profit. It's the thing that you want to either maximize or minimize. And in this case, it says maximize profit. So you just set it up by going across. It is 5x plus 8y. But it should be equal to something. So I think in your notes and on your worksheets, they had it equal to p, right? So we'll just put a p there. That's the thing that you're trying to maximize. The constraints, and this is where you do have to be a little bit careful with the word problems, but you always just head across, right? And I can't go over 7 cups. I'll head across and I can't go over 12 cups because that's all I have. So when you set it up, you have 1x plus 1.5y has to stay under 7. It runs straight across, Betsy. Does that make sense? So then for the sugar column, I only have 12 cups of sugar, and I use a half a cup for every batch of lemon poppy seed, and I use a full cup for every batch of gingerbread, and I have to make sure I don't go over 12 cups because that's all I have. That's why they call it a constraint. All right, there's 2, though, that are not explicitly on the table that it's easy to forget. Do you guys know what they are? There's 2 others.
Yeah, I know.
What are they? Thank you. Yeah, you have to at least use some flour, or no, you can't use negative cups of flour. Don't forget these 2, because that's an easy point, but it doesn't come right off your table. So when you take the test, you'll set it up exactly the same way. Whatever 2 things you're working with, it won't be muffins, but it'll be something. You put the X and the Y, you go fill in the table with the appropriate data, and then you run straight across X, 1x plus 1.5y, keep it under 7, and it works out. And that's all it says. You don't actually have to solve it for this word problem. The solving comes from the problem above it. And we did that one yesterday and recorded it. But would you guys want to try just this one? Just make sure you have the solving part down. Let's do it. All right, good. I'm glad you said yes, because I wasn't going to force you to. Those of you in the A group, you know, we did this one already, so you can shut the video off. You guys just asked me to video that last one. All right, so this right here doesn't do much for you in terms of work. All it means is keep it all positive. So it basically just means go to the right and up and stay in the first quadrant. So it just means don't leave the first quadrant. So there's really nothing you have to do. And then Parker, how would you graph this first constraint where x plus y is less than or equal to 7? Yep, so he's going to go y less than or equal to, and he moves the positive x over as a negative. And then we'll go to the 7 on the y-axis. We'll use a slope of -1, and I would just walk it all the way down because It'll save you some work later in trying to find intersections if you walk your way all the way through the first quadrant. And then just connect it really nice. I'm doing a solid line because that said less than or equal to. And then in my mind, I'm thinking I need to shade under it. If you just have a pencil and you don't have, like I have access to these tools here, so I can shade under it, let's say with yellow. So when I shade under it with yellow, because it said less than, but I don't leave the first quadrant. Oops, my screen I think moved a little bit, didn't it? Here, just a second. Oh, good Lord. There we go, perfect. Back to, am I killing you, Bets? There, move my screen. So that's everything that meets the first constraint here in yellow. And I didn't leave the first quadrant because of these guys. And this one I do the exact same thing. I'd move that 2x over, but you do it by doing the opposite. So make sure you add it over. All right, then I'm going to take a different color. I'll go blue. I'll go to the y-intercept right here. Mason, with a slope of 2, what will I do? With my pen, up 2 over 1. And you can see this guy right here that I just double hit is going to be an important point for us. But it's going like this. And I'm not supposed to leave the first quadrant, so I doubt they'll take points off if you go like that. But I'm now done. I just need to make sure that I find the minimum and the maximum. So what I do is it can only be at these corners of my shaded region, and I had to be under both lines. So under the first line was in yellow. Under the second line is in blue. So you'll see when the yellow meets the blue, it's making a green region. That's where all your solutions are. But the corners of the green region are the ones that you pull off and you write them down. So my corners are 0, 0, and then this guy right here, 0, 4. If you graph it neat enough by using that slope-intercept method and doing dot by dot by dot, this is usually really easy to see, right? That's at 1, 6, right? So 1, 6. And then over there in the far right is 7, 0. And then do you know, Betsy, what you do with these numbers? Yeah, you can't hear, but you said you plug them in to that objective function for your profit. We'll see, well, I don't know if it's profit because it didn't say, but for P. So I just go here and I say, well, 2 times 0 is 0, plus 5 times 0 is 0. So the first one gives me a P of 0. The second one is 2 times 0, which is 0, plus 5 times the y value. So this one's going to give me a 20. Pretty big number. Might be my maximum. The next one, 2 times 1 plus 5 times 6. That's going to give me 2 plus 30, or 32. That probably is my maximum. And my next one's going to be 2 times 7 plus 5 times 0 for a 14. So now I have to answer the question. For this one, it said to find the maximum and the minimum. So make sure you go over here and say max. The biggest was 32, and that was at 1, 6. So 1, 6. The min occurred at 0, 0. We'll add in there. What do you think? You do it on your own, you think, kids? I'm going to turn this off, and I think you guys in here, A group though, make sure you look at this like you'll be testing Monday. I will see 2 of you because you're in the afternoon, but the other 3, you're going to be taking it before you see me. So I'd maybe run through these again, but I think some of you have found them to be pretty helpful. I'm going to go